to look at here, if we look at this very first even number, problem number 64, is just the idea that you are expected to know the conversion between radians and degrees. Okay, so see if you can answer this question really quickly. It requires you to have remembered that. I'll go through it here in just a moment. It is also included in the material, or the reference material. So the reference page that you have accessibility to looks like this. And you can see right here that it says the number of degrees of an arc is 360, the number of radians is 2 pi. So it gives you the conversion right there if you forget. And the reference material is in a pull down. So like when you are on your app, if you want to access it, there's like a little button at the top, I think, that links to the resources or reference information. Okay, so the conversion they give you basically is 360 degrees is equivalent to 2 pi radians. Now, we use 180 in pi, okay, but in either case, you have your conversion. Okay, and so if you just take the given radian measure, 31 over 30 pi, this is in radians, and you convert the units for converting from radians needs to go on the denominator. So 2 pi radians in the denominator, 360 degrees. The units cancel. Again, you have the pi's cancel. You can reduce it to 2 goes into 360, 180, or very likely you used 180 over pi as your conversion. You can continue to simplify with simple mental calculations. 30 goes into 180 6 times. And so if you took 6 times 31, you get your answer here of 186. Okay, but do be aware of what the reference information contains. It has some of the area volume formulas, the special right triangle formulas as well. All right. The material that follows this is stuff that's a little more commonly covered in the high school curriculum. So I'm going to jump all the way to 78 because I do want to talk through any place where I can show you strategies that are maybe a little bit different than what we do in a classroom here. Okay, so I want you to see if you can answer this question here. 78, this is considered a very difficult question, okay, but I want you to approach it how you think you would, and then I'll go through it and I'll show you what I hope is a much simpler way to approach it. If you are approaching this the mathematical way, or if you look at how the problems are like kind of worked through mathematically, this one is a little more complicated in the way that you do it. So if you know you have these 9 integers plus there's one more, I'm going to call it A because I am going to use the slider on Desmos calculator. Okay, but like this is going to give you a total of 10. And so if you're finding the mean, remember a mean, median, and mode are sort of the central tendency concepts that are covered most. It also has frequency and it has range as well. But mean is the average, median is the middle number when you rank them from least to greatest. And so if this says that the mean is going to be an integer, what that means is if you take the sum of all these and divide by the number of them, which is 10, you're going to get a value that is an integer. So if you add up everything that you have right here, and again, I'm not going through the steps of this, I'm just talking through it. But the sum of the 9 values that are included is 333 plus A. So you know that this over 10 has to equal an integer. Well, it's based on the concept that A has to be a number so that the numerator and the denominator of 10 can cancel as factors. So we know that A has to end in a 7, right? That way the total sum of all those is going to end with a 0. So that's sort of the complex property that they are actually testing mathematically. The nice thing with Desmos is you can do this problem very simply by just typing all of these pieces into a table. And you can also create a list, but because the table's useful, I'm just going to enter the information in the table form instead. Right? If you experiment with Desmos, you can do the central tendency problems with lists rather than table values. All right, so I'm going to include all of those, and I'm going to put A in this table. Right? Now, I need to create a slider for A. If it doesn't prompt me automatically to do that, just give it a value. A is equal to 1. That's just what I'm going to start with, and I'm going to use the slider to find values for this. Okay? Now, I want to find that the median is greater than 37. So what I want to do, or sorry, the mean is greater than 37. So inside of this keyboard here under functions, again, get familiar with what functions they have. So all the trig ratios are in here. We'll talk about it here in a second, but if I don't get to a problem specific to that, when you're using trig ratios, you have to make sure you're in the correct mode. Okay? So you're most likely going to be working in degree mode. Desmos is automatically by default set into radian mode. So if you are going to take the sine of something, so if I wanted the sine of 180 and I type it in here, if we know the sine of 180 is 0, okay, this is giving us the wrong answer because it's in radians. If you go to this little, if you go to this little wrench tool, this settings tool, you can change the mode right here. So I would change it to degrees, and once I do that, then I see that it actually gives me the correct answer. Okay, so do be careful with that. Make sure that you are in the correct mode for these. All right, so back to our problem that we're working on here. Once you set your A value, what we need to do is inside these functions, there's also the statistical or central tendency functions. Mean, median, those would be the ones that you would most likely use. So if you take the mean of, and notice that this is all in column X1. So I'm going to take the mean of X1, and it shows me 33.4. I want this mean to be an integer greater than 37. So I need to find out what value of A gives me that. So as I start sliding A up, I'm watching this number. I need this number to go above, to be an integer greater than 37. So I need it to be 38, right? So I'm going to slide this until I get to 38. Notice I run out of room in my slider. If I just click on this, I can set my maximum and minimums. So I'm just going to set my maximum to 100 here. And now I can slide it and keep sliding up. And actually, because I'm working with integers, my step, I can change it to 1. That way it doesn't go through decimal points. It's just every number as I slide is up by 1. Okay, and so I'm going to continue to slide this until this mean gets to 38. So here I keep going right there, and that's my answer. 47 is the solution to this. And it's super simple, a lot less complicated than if you kind of follow. And I think in one of the videos I show both. I show the mathematical way too. But it's way more easy to let Desmos do all the work for you. And this is a problem that is considered extremely difficult for students. So get used to using the calculator for things like that. Okay, just really quickly to practice the mean. See if you can find the average of these. You can, again, do it by hand, but if you have access to Desmos and the calculator for finding the mean, go ahead and do that the quicker way. Okay, so as you're working through that, again, I'm going to enter my data in a table rather than a list, although if you go in and look online, you can find the sort of instructions on how to create a list from these, but I'm just going to list all my values. I'm then going to come down here and I can just type the word mean. I can access it through the function. I'm going to identify the column that has the list that I want. And so what I see right here is my average is 8. And I didn't have to do anything other than type the list and know what I'm doing. And if you needed to find the median of that, this word would just change to median, and what you would find here is that the value that is in the middle when you rank these from least to greatest is 7. And there is no 7 in the list. That means that there's an even number of values, and that the median is the average of the two middle values. Okay. All right, and so again, here's the concepts that you would be most likely to have to work with. All right, the next problem, I do include this because I want to reference a concept that, or a table or a presentation of data that we don't really focus on here, which is called this box and whisker plot. The way that this is set up, and again, like I know I can't recall really ever teaching it other than for the SAT. But the boxes represent quartiles, which the SAT is not testing on. The whiskers give you the ranges. So this is the least and the highest value, the least and the highest value. But the thing that you have to actually understand is this vertical line. Okay, so you might actually, the two concepts from a box and whisker plot that I've seen questions asked on the SAT are something about the range. Okay, what is the total range between them? But most of them are talking about this vertical bar inside the box, and that is your median. So if you understand that that's where the median is, that's usually going to be the focus of the question. So see if you can answer this question based just on like what you see here and the fact that that little vertical bar inside the box represents the median score. Right, so when you look at these, you can't tell anything about the mean, the average on these, because it doesn't give you the frequency of each score. Okay, but you can tell where the median lies. And so when you're looking at this, the median of group 1 is a little above 25, but between 25 and 30. The median of score 2, or group 2, is between 30 and 32, a little above 30. So you know that group 2 is the higher one. And so when you're looking at this, group 1 is greater, no. Group 1 is less, yes. Okay. So that would be the answer for that particular question. Okay. But again, it's just being familiar with what that type of graph looks like. All right, so again, I'm going to jump ahead a few to make sure that we cover some of the geometry material, as I mentioned before. Anything that you're going through that is unfamiliar to you, please feel free to look at the video captures from the Canvas site, and if you have any questions about how to do something. All right, with regard to triangles, okay, the majority of what you're going to be asked to do with geometry is likely to include triangles, and more than likely it's going to be something to do with right triangles or right triangle trig. Okay? If it's right triangles, if it's triangles in general, it's either going to be triangle sum, right triangles using Pythagorean theorem, or right triangles using trig ratios in similar triangles. Okay? So those would be the most likely concepts. So I want you to try 94 here really quickly. See if you can answer this question. So if you model what you have in this particular problem here, you are looking at 2 trees. So here's one. Here's a second one. They're on the same flat ground. Okay, and it says that a 44-foot tree has a shadow length. And again, the hypotenuse of this triangle that I'm drawing is just the path of the sun, right? So this is called an angle of elevation here. Well, because of the nature of, even though like right here in our drawing, it might not look like it, but anytime you have objects that are right next to each other or very close to each other, they have the same angle of elevation to the sun, okay, on any given part of the Earth's surface. So this other tree over here, what you see is it's going to cast a shadow with that same angle of elevation. Well, the fact that these trees are perpendicular means that the triangles are similar by AA similarity, right? They have the same right angle and the same angle of elevation. So two angles makes them similar to each other. And so you're told what the shadow lengths are. For the taller tree, the shadow length is 11. For the smaller tree, the shadow length is 8. And you don't know what the height is. Right? And so similar triangles have two properties. They have sides or angles that are congruent, and they have sides that are proportional. Right? And so for this, you're going to use proportional sides. So if you relate to the two corresponding pieces, so I would start with my unknown, h, and h corresponds to the height of the other triangle, 44, in the same ratio as the shadow of that small tree, the same tree where h came from, which is 8, over its corresponding shadow of the other tree, 11. And so here's the calculation you'll use. Multiply both sides by 44 to get height alone. And when you do, 11 goes into 44 4 times. 8 times 4 is 32, and that gives you your other height. So this is the concept of similar triangles, and using the similar triangles have congruent angles and proportional heights, or proportional side lengths. All right, go to 96, see if you can answer that problem, please. All right. If you are working with a problem that has reduced radicals, like this right here, we saw one earlier where we had the square root of like 4 plus the square root of something in one of the quadratic equation problems. If you see a radical or it's asking you to reduce a radical, TID9 is probably going to be your best bet. Okay? So I strongly encourage, take the TID9, but know how to use Desmos and be willing to go back and forth between the two. And this is where the practice comes in handy. So if your test is tomorrow, you may not have a whole lot of time to get familiar with one or both of those calculators. If you're going to retake this in the fall, or if you're not taking it until next year sometime, or even if you're taking it later, like in June, you have some time to get familiar with it. Find out like where Desmos works best for you, where the TID9 works best, but have both of those with you, because take advantage of the strengths of each. Okay, so on a problem like this, you have a right triangle. So this is going to be just the regular properties of a right triangle, like Pythagorean theorem. Okay, you have legs of 56 and 49, and you want to know what is the length of its hypotenuse. And so if you are using a TID9, you can set up Pythagorean theorem, 56 squared plus 49 squared equals c squared. And you can solve this. And you can either replace c with x and make it simpler, or you can actually use c for this. And if we do that, I'll use the TID9 first, because this is where what I would recommend for a problem like this, is go into the solve feature, type in your problem, so 56 to the power of 2 plus 49 to the power of 2 is equal to, and I'm just going to use x here so I don't have to hit extra buttons. And then I'm solving for that x, my unknown hypotenuse, close off everything. And if I'm in auto mode, it will reduce the radical for me. If I'm in approximate mode, I want to change it, because we want this radical form. And I get 7 root 113. And so d is the part that's inside the radical. And so my answer is going to be 113. Now, if you are going to use Desmos for this, you can still do it. It complicates things slightly. So if I think of that as the square root of 56 squared plus 49 squared is now equal to my c value. And I know that this is equal to 7 times root d. What I can do is I can put that 7 inside the radical. When I move 7 inside the radical, it becomes a 49, right? Because the square root of 49 is equivalent to 7. So I'm just putting it into its form here. So if I take this number, this whole calculation right here, I can take out the 49. And what's left of this is going to be what's inside my radical. So if I know that 49d is equal to this, what I can do is I can go into my radical here, 56 squared plus 49 squared. I can take this whole thing and divide by 49. When I divide by 49, what's left is going to be what's representing my d value, that factor d. So you can still find it, but if you have access to your TI-89, it's going to be a lot easier just to rely on that. All right, the final type of triangle question that you will likely see, this one is an odd question, but I do want to go through it, is jump to question 99. So this is like a really typical type of right triangle question that you can expect to see. It involves similar triangles and trig ratios. Okay, so see if you can answer this question, please. Or actually, this one doesn't have similar triangles, but like it's just the trig ratios for that. But you can expect a combination of the two as well. Okay, here's a reminder. So KTOA is the acronym for helping to remember the patterns for the 3 trig ratios you're responsible for. And remember, we're looking at trig ratios for SAT, you're looking at trig ratios with regard to right triangle trig. So one of your angles, theta, will be the acute angle of a right triangle. And with regard to that triangle, you have 2 legs. One leg is opposite the angle, one leg is adjacent to the angle, and then you have the hypotenuse. And so that's where the different ratios come from, right? O's correspond to the opposite leg, A's correspond to the adjacent leg, H corresponds to the hypotenuse. And so that's what your ratios are. So if you look at this problem right here, you have a right triangle with angle S as the right angle. So it just means that R and T can be associated with either one of those angles. It doesn't matter how you set it up. But you're told that the sine of R is root 6 over 20. So the sine is opposite. So opposite R is root 6 over hypotenuse. Hypotenuse is 20. And so once you set up those 2 known pieces, you can answer your question. Now, it is possible to look, even before you start using Pythagorean theorem, to find what is the missing side length. Just look and see what the question is asking you for is the let's see. So this one is supposed to be, this is supposed to be T is 90. Let me rewrite those. Okay, so if the T is the 90 degrees, and it's asking you now, solve for the cosine of S. So the cosine is adjacent. So with regard to angle S, you have the adjacent and the hypotenuse. Well, we already have those values. The adjacent is root 6. The hypotenuse is 20. And so you have your solution right there as it sits. Now, if it had asked you for the cosine of R, if it was asking you for cosine of R, then you would have to add the extra step of finding that measure. Okay? And so if we called this x, you would use Pythagorean theorem. X squared plus root 6 squared equals 20 squared. So we're going to subtract root 6 squared is just 6, and then extract the root. So if we took 20 squared minus 6, and then took the square root of that. Again, when you're working with square roots, it's probably easier to use the TI-89 because it will give you exact answers, which is usually or very often what you're going to be asked to solve in. So if we want to take that original equation, x squared plus root 6 squared, which is just 6, set that equal to 20 squared, and then solve for x, close everything off. This will give us the reduced form. It doesn't reduce at all, so root 394. And so if we were finding the cosine of R would be adjacent, root 394 over hypotenuse, which is 20. So that would be our answer depending on what question they're asking. But normally it will likely be integer values that like easy values to work with. So it would make sense here that they would ask for the cosine of s, where you're dealing with just the values already given. All right. The final concept that I want to talk about involving geometry that you will likely be asked to work with is the equation of a circle in a coordinate plane here. And so this is your equation. It really is just the distance formula, and the distance formula is based off of Pythagorean theorem, so it's all connected in that way. If you have the center of a circle that is hk, the radius is r, that looks like I put a right angle there, but this is your radius. Okay, and the formula that you're going to use is x minus h, the x coordinate of the center, plus y minus k, the y coordinate of the center, is equal to the radius squared. So if you were looking at something like this, here's your h and k value. Here it tells you a point that lies on the circle. And so what you can do with something like this is you can plug it directly into that form. So x minus a negative 7 squared plus y minus the k value, a negative 3 squared, is equal to r squared. And so all you need to know, first of all, you can eliminate two of these choices, right? You know that it has to either be the first or the last choice based on the signs inside. And so your radius is either 10, or either the square root of 10, or it's 10. So when you look at this, if you find and plot this given point directly into this equation, plug in a negative 1 for the x, plug in a corresponding 5 for the y, and you can determine, is your r squared value going to be 10 or 100? And so here you get 6 squared plus 8 squared, 36 plus 64 is equal to 100. And so that's going to be your correct answer. So plugging it directly into that equation for a circle and will allow you to solve. Okay, the second type of question, the slightly harder type of question that you're likely to see for this would be one where you need to use completing the square to find a given equation. Okay, I want you to see how you would answer this. Again, we'll talk through it here in just a moment. Okay, but again, this is as hard a question as you'll see with circles. Okay, I want to see if you can solve that on your own before I talk through. In order to write this given equation in a form that looks more like this, the sum of two binomial squares, you need to complete the square for the x's and you need to complete the square for the y's. So your steps for this is group your x terms together, leave a space to complete the square. Group your y terms together, leave a space to complete the square. Move your constants over to the other side. Okay, so that's the first step. Second step is to complete the square. To complete the square, you're going to take half of your first degree term's coefficient. So half of the first degree term is a term with a power or degree of 1. So half of positive 1 is positive 1/2. So you're going to take half of that. You're going to square it, and you're going to add it to both sides. So if I add 1/2 squared, that's equivalent to adding 1/4. So I need to balance my equation by writing 1/4 on both sides. Do the same thing with the y's. Take half of my first degree term's coefficient, which is also half of 1 is 1/2. I'm going to square that and add it to both sides. Adding 1/2 squared is 1/4 once again. And the whole point of doing that process is it allows me to rewrite the x's as a binomial square. So I completed the square so I could write it as x and then whatever the number is in here. Notice I included the signs. When I take half of that first degree term, I include the sign here simply because that's going to become my binomial square. I do the same thing with the y's. Y, then the plus 1/2 squared is equal to, and when I combine all of these, 1/4 plus 1/4 is 1/2, 161 over 2 plus 162 or plus 1 over 2 gives me 162 over 2, which is 81. And so if 81 is my r squared value, that means my radius is going to be square root 81, plus or minus 9, but since we're dealing with a measure, it's 9. Now, you could on Desmos type this equation directly in as well. Here's, again, the pluses and the minuses of this. When you type this in, it works well to confirm our answer, because if I zoom in on this circle here, so it plots the circle for me. If I zoom in on it, I have an idea of what the lengths are. Okay, so I have my center. I know my center right here is the point negative 1/2, negative 1/2. But if I look at the distance from my two endpoints of this diameter here, oops, I'm going to zoom in a little bit. So when you look at this circle, it gives you your, right here, this point on the circle and this point on the circle. And notice, how far apart are these two? These are two endpoints of a diameter here. How far apart are those 2 points? Negative 9.5 and 8.5. Those are a distance of 18 units. The radius is half of the diameter, so half of 18 gives you 9. So you could have solved this visually by plotting the circle and then looking at the points on there that you can identify lengths for.